Hello, my name is Fiset-Algarvio, and this is Project POV Dual 7-Segment Display Application. So first off, you got the 8 switches, which would represent the binary number, which go into pins A0, A1, A2, A3, A4, A5, and 12 and 13. And then you got 2 dual 7-segment displays, which go into the network pins, or network resistors, which go into the Arduinos in pins 1, 2, 3, 4, 5, 6, 7. So it goes from here to the network pins to the dual 7-segment display. You also have the NPN 3904 transistors, which go into pins 8, 9, and 10 in the Arduino. So it goes in there, and then it would tell me which digit to be on. And then it goes back to the computer to be programmed. So how this circuit works is that you got the 8 switches, each controlling one binary digit. So you got 1, 2, 4, 8, 16, 32, 64, and then 128, which input up here, and then the output down here into the dual 7-segment displays, which all of them are connected to these 3 pins. And then the transistors decide which pin to stay on. It looks like they all go on at the same time, but what really happens is they each change from being one on at a time. So this makes sure this is on, and then this makes sure this is on, and this makes sure this is on. So it changes. It's going so fast that it's not able to be seen according to the human eye, but it's constantly changing. Even in this video, you can see it changing just a little bit. So and how to determine if these are on, it's connected to pins 8, 9, and 10 in the Arduino. So like it's gonna stay on, and these 2 are off. This one's gonna be on, and these 2 are off, and then that's gonna be on, and then the other 2 are off, and that's gonna repeat that sequence forever until I ask it to stop. Here is my code for the POV dual 7-segment display application. So first off, I've set variable pins. For the transistors, it's 8, 9, and 10. For the switches, it's A0, A1, A2, A3, A4, A5, 12, and 13. And pins 1 to 7 for the dual 7-segment display to display these combinations. So that's a combination for 0, that's a combination for 1, that's for 2, that's for 3, that's for 4, that's for 5, that's for 6, that's for 7, that's for 8, and that's for 9. Now down here in the setup, I've set the 1 to 7 and 8 to 10. So the transistors and the combinations to be outputs, and I've set the switches to be the inputs. Now in the loop block, I've set another variable called index to be the decimal number that will be used. So if the first switch is on, its index is going to be added to 1. And then you got the 2, and if the second one's on, it's going to add 2, and then for so on and so forth for the other 6 digits. And then once it goes through that, it's going to create the index into 3 different digits. So the hundreds, say I had 64. So 64 divided by 100, that's 0, because Arduino code doesn't like decimal numbers. So it's going to be 0. 64 minus 0 is 64 divided by 10 is 6. Because it doesn't like decimal numbers. And then 64, so that's 0, that's 6. And then so that minus that, so that's 64 minus 60, that's because 6 times 10 is 4, and then minus 0, so 4 minus 0 is 4. And there you got 0, 6, 4. Now, over here, got high. If the transistor 1 is high, which is the 100th digit, it's going to display high, and the others will be low. It's going to display the 100th digit, which is 0. Wait 5 seconds, and go on to the next one. Transistor 2 is on, it's going to stay high, the other 2 are off. Displays the 10th digit number and 0. And then, wait 5 seconds. And then transistor 3, if 3 is going to be high, others are low. Displays the 1-digit number, waits 5 seconds, and keeps repeating that until either a change in decimal number. So if say it's like 1 and 64, it's going to be all that's going to change to 65. So that and that's going to change to 60. So 0, 6, 5, 0, 6, 5, and instead of 0, 6, 4. It's going to keep doing that until another change has happened, or I ask it to stop. And that's how my code works. Thanks for watching.